Hi, I'm Sridhar Gopalakrishnan and is a member of pgpcc March 2018. And as a part of the Capstone projects, there were very exciting topics that were offered by the Institute for our selection. And while going through them, I was greatly influenced by the Slack app Capstone problem statement, which actually realized a messaging channel and an aggregator for the various messaging applications. So what I planned was to attempt developing a Slack-like app, which is a basic messaging app, because of the time available for us to develop was only that much in the midst of our official time. So I chose to develop a messaging app which looks like Slack, which essentially uses the features offered by the basic messaging feature offered by Slack, using all the AWS services, tools and managed services taught to us throughout the course. So what I have attempted to is developing a messaging app which looks like Slack and which allows a user creation and a successful login with a persistent storage of users into the database, and then creating a chatting channel and using that channel communicating with any other user who would log into the same channel, which is what essentially Slack provides. There are many feature enhancements possible to this, and which could be done provided we had enough time and feature scoping. In addition, I have tried to ensure that we have built-in scalability and security provided by the AWS tools. Now let's look into the high-level architecture of how we have tried to realize this messaging-like app solution using the AWS services that we have learned throughout the course. So at the core of this, the user interface, for simplicity's sake, user interface, I have designed it like a command line and based Java application, jar, which has minimum options like creation of the user, login into the user, creation of a chat group or a channel, and then write the message. Along with that, I have also tried to add a logic that because it's an open broadcast channel, any of the messages that we ourselves write will not show up in our window. So that is a filtering that we have done at the application. So that Java application is the trigger. Is the trigger for the various options. And for user creation, and we have used the AWS API gateway, which provides a REST interface, is for posting the user data into the database and a get of the user details during the login. And we will get into the details with the AWS screens later. Let's just go through the architecture diagram here. So it goes through the AWS API gateway, which provides the REST interfaces for the login, and the creation of the user data and storing that into the database is achieved using an AWS Lambda function. We can have both options. We can have an EC2 and provide elasticity, or we can use an API gateway and Lambda functions to have a serverless architecture. We have chosen to do a serverless architecture for its simplicity, and also it provides a seamless way of scaling it up as AWS itself does it. But cost will come to a consideration after we reach a certain volume, by which time moving to an EC2 would be beneficial with the reserved instances, etc. Anyway, for the time being, we have chosen to go with the AWS Lambda function way, and we have Lambda functions which actually writes the data into the database and gets it. So the date, and there is an option provided for storing the chat messages into S3, but essentially talking about the user registration and access, we have used the persistent storage, which is AWS DynamoDB. So the AWS Lambda functions will interact with the DynamoDB and store and get the data. Now, talking about the security mechanism needed, AWS itself provides the KMS, the Key Management Service, which provides option to encrypt and decrypt the password. So we have used the AWS KMS also in the AWS Lambda, which is essentially the Python script, to get the password encrypted and decrypted. We will go through the source code in a short while. Then AWS Route 53 is used for the DNS routing, and which essentially decodes the URL and from there connect to the relevant services used. For the message channel purpose, AWS provides a ActiveMQ, which is the active message queue, which can be used to send, or AWS SQS, etc. all uses active message queue to open a channel and send the messages into the channel. So we've used the active message queue for the messaging purpose. The chat messages currently are not persistently stored. We have only given an option for that to be stored in S3. So this is the high level architecture using which the messaging is realized. And we have another end, we'll have another user which will again go through the creation and login and joining the same channel. Talking about a typical flow diagram, we will have a user who will go through the AWS API gateway to create the user database into the DynamoDB, and and while login gets the same access data from the DynamoDB back. After that, there is a connect request that is sent to through an active MessageMQ, which is then used to establish a channel, and after which we can send the messages. So there is a very simple message flow which we have conceived for its for the time that we had to complete it. And the AWS functions that we have used, as I said, we have AWS Gateway, Lambda, and DynamoDB and Active Message Queue. One thing which is noteworthy here to say is that AWS now has exploded in its in its offerings for managed services, and for message queue it provides a instead of active message queue, we can very well use an AWS managed service which is called AWS App Sync, which provides the real-time data-driven apps and offline capabilities, which provides a mechanism to update the message status and into the other users' mobile phone or screens dynamically. So this is a much higher level sophisticated messaging service that we can use, and of course it comes with its higher cost for the managed services that it provides. But for simplicity's sake, I have not used AWS AppSync in this demo. Now let's get into the AWS configuration and the resources that are created for realizing this messaging app. So, and I've done the project completely in my personal account, which is what we will log in now. So it shows here SDG personal, which is kept in North Virginia. So the resources that that we have created for this project is, as I showed in the architecture diagram, we need to go through an API gateway, and API gateway is nothing but provides the REST interfaces is to reach out through the Lambda function to the DynamoDB, and you can see that there are okay. So there is a messaging API, which is created for this purpose, which is basically the REST APIs for the messaging server. If you select that, you will be able to see the post, and post is nothing but there is a method request for it which calls the Lambda function messaging API. And if you click the Lambda function, you can see the source code of the Lambda function, which has supporting functions for encrypting and decrypting the password using the AWS KMS key management service I already mentioned, and also get the information from the jar and create the user record and store that to the DynamoDB, which is what is assumed, which is what is performed by this Lambda function, and which is written in Python. The source code is shared and in the site where we submitted the project. Let's go back and look at the other Lambda function. So going back to API gateway, so post basically creates the user info and writes it into the DB, and there is another REST API function get, which is again written as another lambda function get users. This get users gets the login when a user logs in through the Java interface, jar interface, it gets the user information from the DynamoDB, which is again another function written in Python. It's written in Python 3.6, which has similar functions, which basically gets the data from the DynamoDB and presents it. Now let's look into the next service, which is so we saw API gateway. Now we are in Lambda. You will be able to see the Lambda functions, which is what we went through. These two, you can see that you can see that there are two Lambda functions written, and their code size and the last modified, etc. Then we will go to the DynamoDB part, and the DynamoDB, there is a table created which is still active, which is for storing the created user information. This is one table which you can see as active. The name of the table is users, and its read capacity is kept as 5 and write capacity is kept as 5. And that is essentially for storing the user information. Basically for the user creation and login, that's all that is done. There is, as I said in the beginning, there is no EC2 created because we have attempted a serverless architecture going through API gateway called by Lambda functions, and Lambda function doing all the functionalities needed. The second path, once the user is created, the next path is about creating a channel and communicating to that channel, which is realized using the Amazon MQ. So which is nothing but the active queue. Amazon's AWS managed system for active queue is Amazon MQ, and Amazon MQ we have created one resource here, messaging app, which is a single instance broker configuration and of an instance type T2 micro. Again, this is only for the demonstration purpose. As I said in the beginning, this is something which we can scale easily depending on the volume of chat usage. And the configuration, there is a single instance broker, or you can have it deployed in multiple availability zone. So for current demo purpose, we have chosen single instance broker. See here. So when we really need to scale up, we can go to the active standby deployment. And the broker instance type is T2 micro, and all the relevant information with respect to the instance is given here. That's all the AWS services that we have done. So we have gone through all the live resources which are created here for realizing the messaging app. Now we'll see the final running of the messaging app solution that we have created. So for the demonstration of how it is working, we have the jar file which needs to be copied into two folders so as to simulate two different users, and then we will try creating two users at both sides and try to enter both the users into the same chat channel name, and then we will see the messages sent from one user is showing up in the message shown in the other user. So what I have done here is I have created two folders, user 1 and user 2, and copied the same jar file into both, basically telling that it is two different instances which we need to, two client instances that we need to run. So you double click here, you get the screen for the first user. As you can see, it is, I'll just take it closer. You can see the options: sign up, 2 join group, and 3 exit, etc. Now you can see the user 1 options. When you run this jar file, it will show first one is sign up, second is join group, third is exit, and choose your option. So we are going to create the user 1 here. So select option 1 and email. You can let me just try to give, say, my son's email, which is kaushu@gmail.com. Then it is asking for username, so put it as Kaushu. Password, so give some password, ABC123. Confirm, ABC123. Age, so put age is 16, and wait for the user creation to happen. So it shows that successfully created user. Now this user, you will be able to see this user in the say the DynamoDB, that table that I just showed while explaining the AWS resources. So you can see that the newly created user is, say, Kaushu, which I have highlighted, and that is present here. So I have created many users for testing purpose, but kaushu@gmail.com is the most recent one that I have created. Okay. Now let's go back to, sorry. Yeah, now let's go back to our input program. So we have successfully created the user Kaushu, and next thing is to join a chat group. So give the option 2 here, and it asks for, okay, which is, so once you wish to join a chat group, it is going to make you log in to verify the user. So you have to mention the same email ID which you have created. So I am typing here kaushu@gmail.com. And the password, whichever password we used to create. Good. So the user has joined. The user has successfully logged in for joining a channel. So or a group, chat group. It is asking the group name. So I'm going to give the name of my apartment as the group name. So say Wars 1. So it's creating a chat group using the Amazon MQ. As you can see, it has created, and it is showing now Wars 1 Kaushu. Next thing is to create the user 2, and you can say hi here. Okay. Now the next thing is to go to and create the user 2. In a similar fashion, you by sign up and create say ranch@gmail.com, which is username Ranju, password ABC123, ABC123, age say 34, and you have created the second user. Again, let's go back and verify in the table. Oh, let's take the table again and go to items and see here whether ranch@gmail.com has been created with age 34. So this is, as you can see, the highlighted table which you can see in blue color is what the second user which I just created. Okay, now we are going to make the second user join the same chat group. So I pressed option 2, and it is asking me to log in here. So I'm doing ranch@gmail.com, which is the email ID of the second user which we just created. Password ABC123, and user and it is asking enter the group to join. So I am going to give the same group which we created there for the first user. Okay, so it is showing that it has entered the group and is showing Wars 1 Ranju. So I am keeping this window here. So I'm keeping two windows side by side, and now let's try chatting. Say hi. When you create hello, See, when you type in a new message here from user 1, you will see the message from the other user Ranju, hi, on the user 1 window. Similarly, let's try another message. This is Ranju here. And at that time, you saw the message received from the other user, Kaushu, hello. So this is how the message from the other user is displayed, and the jar file in the Java code, I have taken care that the message from our own window does not show up again on the same window. So which is like it will be like duplication, so that we are doing an elimination. Okay. Thank you. So this successfully demonstrates that the two users can chat with each other, and the chat is realized using the Amazon MQ. So this is the intention of the project, and this can be seamlessly scaled for including any number of users. And we just have to change the configuration of MQ to the multiple availability zone in order to make it really global. And currently the Lambda function will scale by itself. Thanks a lot. I hope you have seen the demo well and have understood how we have realized it. Thanks again for giving this wonderful opportunity to work on a wholesome AWS project, and using our learning to create something which can be used, which can be utilized for a generic purpose. Thanks a lot.